The paper of the day is Design and Evaluation of Main Memory Hash Algorithms for Multi-Core CPUs. The focus of this paper is on investigating efficient hash join algorithms for modern multi-core processors in main memory environments. This paper dissects each internal phase of a typical hash join algorithm and considers different alternatives for implementing each phase, producing a family of hash join algorithms. Then they implement these main memory algorithms on two radically different modern multiprocessor systems and carefully examine the factors that impact the performance of each method. Paper uses TPCH benchmark, and they have implemented the hash join algorithms in a standalone C++ program. The program first loads data from the disk into main memory. Data is organized in memory using traditional slotted pages. The join algorithms are run after the data is loaded in memory. Since the focus of this work is on memory resident data sets, they do not consider the time to load the data into main memory and only report join completion times. Let's look at the contributions. First, they systematically examine the design choices available for each internal phase of a canonical main memory hash join algorithm, namely the partition, build, and probe phases. They enumerate a number of possible multi-core hash join algorithms based on different choices made in each of these phases. Second, they show that an algorithm that does not do any partitioning but simply constructs a single shared hash table on the build relation then outperforms more complex algorithms. The simple no partitioning hash join algorithm is robust to suboptimal parameter choices by the optimizer and does not require any knowledge of the characteristics of the input to work well. Finally, they show that the simple no partitioning hash join algorithm takes advantage of intrinsic hardware optimizations to handle skew. Let's look at the conclusion. The rapidly evolving multi-core landscape requires that DBMSs carefully consider the interaction between processing algorithms and the underlying hardware. In this paper, they examine these interactions when executing a hash join operation in a main memory DBMS. They implement a family of main memory hash join algorithms that vary in the way they implement the partition, build, and probe phases of a canonical hash join algorithm. They also evaluate the algorithms on two different multi-core processor architectures. Their results show that a simple hash join technique that does not do any partitioning of the input relation often outperforms the other more complex partitioning-based join alternatives. In addition, the relative performance of this simple hash join technique rapidly improves the increasing skew, and it outperforms every other algorithm in the presence of even the small amounts of skew. Let's talk PS score. Overall, it's a decent read, though, so it gets 8 out of 10 on readability. With 12 pages long, it scores 8 out of 10 on length. It's a measurement paper, and the description of the approach feels average, so that makes it 6 out of 10. Industry value and learning meter is questionable, so it gets 6 out of 10 on each. Overall PS score is 7 out of 10.